Okay, let's take a look at some transformations involving tangent and a quick one with cotangent, because once you know how to do one, you really can do both. And I included the formulas over here in the upper right with, we don't have amplitude because remember the basic graph of tangent and cotangent, they almost look like a cubic, like that. So there is no amplitude. Amplitude only is there for sine and cosine, and it really is just a stretch anyways. The key difference with that, which I've underlined here, is this period. Instead of 2 pi over b, it's now pi over b. So tangent and cotangent have that difference. Otherwise, everything else is kind of the same. I'd even write the vertical shift because it's d over here. The phase shift is the same. And overall, just knowing how to interpret these graphs and perhaps with tangent and cotangent, maybe a little bit more important to plot a few extra points, because we really just have the starting point, the center, I suppose, and knowing where the asymptotes are. So let's go ahead and begin. So this first example, I have a 1 drawn in here because the stretch is just 1, right? Like A is there, it's not stretched at all. So this pi over 2 we know is B, right? B is pi over 2, and the period then is pi divided by B, which is pi over 2, and we take with division multiplied by the reciprocal, so we get pi multiplied by 2 over pi, which the pi's cancel and we get 2. Okay, I wanted to do this example because most often our period and how we start sketching these typically involves some sort of pi because we are in radians. But that doesn't have to be the case. Okay, our period here is 2, and therefore if you confirmed this graph with graphing calculator or GeoGebra, it would be even more precise, right? Because you could scale your axes to whole numbers here, integers. So alrighty, let's get going. I know there was no phase shift, right? There is no movement left or right because there is no C value. We don't have a D value, so it's not, there's no vertical translation either. Let me go ahead and switch colors. So the fact that the period is 2 and tangent starts at 0, 0, and we could confirm that, right? We might even, because I said we might want a extra point or two anyways. Let's go ahead and do a quick t-chart. So if x were 0, we'd have tangent as 0, and on the unit circle, right, at 0 we have the point 1, 1, 0, and tangent is y over x. That's a lot of audio I'm saying, but right on the unit circle, 1, 0 here, tangent is y over x, so 0 over 1 is 0. Okay, and the period is 2, which means I need to go back to -1 here and over 1 to get the full period. And in fact, we could also confirm that, right? If you substitute 1, we'd have tangent of pi over 2, but tangent of pi over 2 doesn't exist because on the unit circle at pi over 2, we have the point 0, 1, and 1 over 0 is undefined. Well, we kind of knew that from this graph anyways. If the period is 2, right, there's an asymptote on each side of there. So I went left 1 and right 1 for a total period of 2. And we could move forward, right, like go over to 3 now. Rough sketch, so it may not be to scale perfectly, that's okay. And there's an asymptote. And go backwards to -3, I probably don't have enough room. Definitely not to scale now, right? I mean, this spacing and this spacing should be the same as well as this spacing. So I realize they are not. again, a graphing calculator or GeoGebra would confirm more accuracy anyways. We're looking at really what is happening here. So now very rough sketch, right? Tangent looks similar to a cubic here, and therefore I know right in the middle here at 2, we'd get another point, and again something like that, and one over here at -2, something like that. And as I had said, maybe get an extra point or two in here. So let's, a great one to do is right in between the asymptote and that center point there at 1/2, let's say. Same thing with -1/2, but this is an odd function. Tangent is an odd function, which means whatever value we get for positive x, we'll get for negative x as well. So let's do that really quick. If x is 1/2, then I'd actually have tangent a pi over 2 multiplied by 1/2, which is pi over 4, right? And tangent of pi over 4 is 1. So therefore at 1/2, my y-coordinate would be 1. And at -1/2, I may have said the same. I meant opposite, right? The x and the y both change signs in an odd function. So at -1/2, I would have -1 for y. All right. And you could kind of eyeball and pencil in the rest. Like here at 2.5, 5/2, right? I'd have 1 again, and same thing here, just to get it a bit more accurate. All right. Well, the other things we can investigate, is domain and range, where do these vertical asymptotes occur, and so forth. So domain, and I would add that our domain, or where vertical asymptotes occur, would have the same values, right? So the domain x cannot be, well, any odd integer, right? It can't be 1, it can't be 3, it can't be 5, it can't be -1, and so forth. So to write an odd integer, the trick we usually do is we say 2 pi, or not pi in this case, because I don't have a pi. Sorry, I'm so used to having pi in our periods. It's a bad habit. Anyways, 2k, that is an even, right? And then I add 1 to make it odd. And then we could just say k is an integer. K is within, so the little e thing is like in an integer. So if I make k 0, right, I have 2 times 0 plus 1 is 1. X cannot be 1, that's true. Let k be 1, that'd be 2 times 1 plus 1 is 3. And that works. Okay, same thing with negative. If you substitute -1 for k, that's -2 plus 1 is -1. So that should cover them all. That's also where the asymptotes occur. Range is just -infinity to infinity, because there are no restrictions, right, in the range. So how is this graph different than cotangent? Well, the stretch is the same, the period is the same, the phase shift is the same, vertical translation is the same. Like, there's so many similarities. The only true difference boils down to, like I was saying with this t-chart, you may want to just get a few extra points in here. Okay, get a t-chart to see exactly what's going on. But because there are no shifts, what I am going to do instead, tangent is an increasing function, right? From left to right, it goes up. Cotangent is the opposite, it's decreasing. And I also know where tangent started at 0. Cotangent, actually, there is a vertical asymptote at 0. So at x equals 0 is our first vertical asymptote. Now with the period being 2, that would mean that I would go over 2, and there would be my next vertical asymptote. Then I'd go over 2 more, and my next one. Okay, and same thing in the negative direction. all right? And therefore, from there, I'd know that, right, there's my kind of center point is on the odds. And it's a decreasing function, so it's going to look like tangent, but imagine, you know, reflecting across the y-axis. I shouldn't say across the y-axis, but in that direction, right? The imaginary, the line of reflection is vertical. Okay, and if we wanted to test that, we could try a few points, like try 0 like we did above, and we'll see it's undefined because cotangent is x over y, right? So on the unit circle, I have 1 divided by 0, doesn't exist. If I do 1, that'd be cotangent of pi over 2. So now I have x over y, 1 over 0 is 0, which is exactly what we graphed. If I did 1/2, okay, then that's cotangent of pi over 4, which again is on the unit circle. I didn't draw it here, but that's at the pi over 4 or 45 degrees, which means x and y have the same value. So again, we get 1. So at 1/2, I will get a value of 1 there. So the period is the same, all the shifts and everything else. There's no stretch from the original cotangent. What is different though, the asymptotes and again the domain, right? We're really saying the same thing. X cannot be, in this case, any even integer. So we just say 2k where k is an integer. Okay, and if you're not comfortable writing it this way, you know, describing it in words is okay. It gets the point across, but mathematically, we could say something like that. X cannot be even. So now if k were 0, we'd get 0. X cannot be 0. Plug in 1, we'd get x cannot be 2, which is true, right? Plug in 2, and so forth. And the range is the same as tangent, negative infinity to infinity. Moving forward. Now we have an example, bit more is going on here. So we do have a b, right? Here's our b, and we do have a c. I didn't translate it up, but that would be easy enough. Just find your first point and then move it up or down. So we don't have a d, and then our a, I didn't stretch it at all, but again, any of those, the vertical shifts or the stretch, if you just do a quick little t-chart for an extra value or two, you'll see where the graph got shifted. Alrighty, I'm going to go ahead and rough sketch here. Okay, draw that x and that y. Okay, now let's go and figure it all out. So the stretch is 1, no stretching factor. Period 2 pi over b. So the period is, I'm sorry, pi over b, so pi over 2. Okay, and phase shift is c over b, so the shift, we get pi over 4 over 2, so divide by 1/2, which is equivalent to pi over 8. So oftentimes with transformations, you think, all right, inside the function, like this tangent, there's a shift to the right, right? And then we do something with a horizontal compression or stretch. Everything in the function is horizontal. So you have to be careful, though, when we have multiple things going on here, to not just assume it's a shift right pi over 4, because you can see right here it's pi over 8. In fact, there's a whole nother set of formulas which I would rather not do. You know, sometimes just knowing what's happening and then applying the rules, I think is a better way to go. But we could, in fact, look at this 2x minus pi over 4 and factor out a 2. So this would be pi over 8, right? If I distributed, I'd have 2x. We're good. distribute here, I'd have 2 pi over 8, which is pi over 4. We're good. Now I could see in this form, there is a shift to the right pi over 8, which is what we got. And then the 2 will still affect the period. All right. So let's take this information and start a graph. The period is pi over 2, but because I'm moved to the right, I can't draw that yet. So the shift is pi over 8. So we're here. We'll just call that pi over 8. And I know that's going to be my center line, and I know tangent increases, so it's going to, do that. But I need to figure out where these asymptotes are. So if the period is pi over 2, then I know, from the center to each side, the entire length is pi over 2, which means half a pi, right? So I only have pi over 4 to the left and pi over 4 on the right. So if I go from pi over 8 and I add pi over 4, I would be at 3 pi over 8, right? Because LCD, I'd multiply by 2 over 2. And therefore we'd get 3 pi over 8. So if that's 1, that's 2 pi over 8, there's 3 pi over 8. All right, now if I subtracted pi over 4s, I need to go the opposite direction. Right, then I'm subtracting 2 pi over 8, and I would get negative pi over 8. Now that makes sense, because here if I'm counting by eighths, right, I went over 2, and then I'll count by eighths backwards. So those are my asymptotes. Let's go ahead and stick with common colors that I've been using. Okay, those are my asymptotes. And then to get the next one, I could continue that pattern. Right? If I'm counting by eighths, here's 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8. So I need to go over 2 pi over 8 would be the first one, and then there would be an asymptote. This last one would be pi, but we're actually at 7 pi over 8 with the asymptote. Let's do negative direction as well. Negative 2, negative 3 pi over 8, negative 4, negative 5 pi over 8. Okay. Ooh, and I started drawing that the wrong way. This is, oh no, yeah, we're in tangent, my bad. I was thinking cotangent. Okay, so all of these are gonna, tend in that direction, but let's get a point in here, get it just a bit more precise. So you could verify, if x is negative pi over 8 or if x is 3 pi over 8, that we do in fact get something undefined. So I'm going to do that down here where I have a little more room. Tangent 2 multiplied by 3 pi over 8 minus pi over 4. So this would become 6 pi over 8 or 3 pi over 4, right? 3 pi over 4 minus 1 pi over 4 is 2 pi over 4, tangent of 2 pi over 4, or tangent of pi over 2, which, as we said, right, on that unit circle, tangent pi over 2 is undefined because our points are 1 over 0. So great, that worked out. Now let's do one more point here. Remember, we're accounting by eighths. So this is 2/8, which is pi over 4. So we'll substitute pi over 4 in for x. So tangent 2 times pi over 4 minus pi over 4. Well, 2 pi over 4 minus 1 pi over 4 is pi over 4, which is 1. Now, as I said in that previous graph, right, if you find from that center to the asymptote, that middle, you should get 1. Maybe if they're actually a vertical stretch or whatnot, that's where that would come into play, right? Getting just a little more precise. If we had that vertical stretch like a 2 here, right, our final result would be 2, and then that's the stretch. But this, in this case, we do not. Or if we had a vertical shift as well, right? If I added 1 here, then again, I would need to move up to 2, because this entire result would be added by 1. So those are easy. So let's plot that point. I'm at pi over 4, 1. And again, an odd function, so I could go back to 0 and hit -1. And I could do that for all of these. 1, -1. Okay, and just get it a bit more precise. You know, the sad part is I have an art degree too. But story for another time. Okay, I hope that helps you out with some transformations. Tangent, bit more tricky, I think, than the sine and cosine and even secant and cosecant. But just remembering the period and where asymptotes occur shouldn't be terrible. So we should actually answer that. Like, where do these asymptotes occur, or what is the domain, right? Same question. Let's go ahead and answer that again. So we had an asymptote. Sometimes it's easier to start like that. Like, where were the asymptotes? We had one at 3 pi over 8 here. Then we had one at 7 pi over 8. And then if we look in the negative direction, it was negative pi over 8 and negative 5 pi over 8. So if I have this start, right, 3 pi over 8, and I add 4 to it, or if I subtract 4 to it, that's one approach we could do. So the domain x cannot be, oops. And again, we might need to play around with it just a little, but we'll start with 3 pi over 8. And then what are we adding? We're adding 4 pi over 8, or subtracting 4 pi over 8, which is equivalent to pi over 2. Right? So plus or minus pi over 2, and then we just say times k, or k pi over 2, where k is an integer. So if I added 1 pi over 2, or 2 pi over 2, 3 pi over 2, or subtracted, I now hit the domain, and I will have hit all these asymptotes. Range negative infinity to infinity. I don't even think we need to write that. Now, I would say this graph is complete.